Hi, welcome back. This is Math, Chapter 5, Problem Solving Investigation, Working Backward. Our essential question, how are integers and absolute value used in real-world situations? What will we learn today? The work backward problem-solving strategy to solve real-world problems. Case number 3, sea level. Mr. Ignacio went diving along the coral reef in Oahu. He descended 12 meters below sea level. The difference between this point on the coral reef and the highest point on the island, Mount Ka'ala, is 1,232 meters. 2/5 of the way up the mountain is a ranger station. How far above sea level is the ranger station? Understand, read the problem. What are you being asked to find? How far above sea level is the ranger station? What's your plan? My strategy is to multiply 2/5 of 1,232 meters because the distance between the coral reef and the highest point on the island is 1,232 meters. So if I just want to know 2/5 of the way up the mountain, I need to subtract this 12 meters from the total distance. 1,232 take away 12 is 1,220. 2 times 1,220, to do 2/5, we multiply the numerator times the numerator. 2 times 1,220 is 2,440. Now I need to divide by 5. 2,440 divided by 5 equals 488 meters. Does the answer make sense? Yes. Case number 4, cameras. Adamo saved 13 pictures on his digital camera for a total of 12,021 1/10 kilobytes. He deleted 32 pictures for a total of 29,590 4/10 kilobytes. If there are now 108 pictures, how many kilobytes of storage did he use at the beginning? Understand the problem. Read the problem. What are you being asked to find? Okay, so there's two different things going on here. We've got the number of pictures going on, and then we also have the size of the storage going on. If there are now 108 pictures, how many kilobytes of storage did he use at the beginning? So I have to use all of this information in order to come back with the solution to this question. What is your strategy? My plan is to work backward. Start with the number of pictures now, 108. I add back the 32 that Adamo deleted. I subtract the 13 that he added, and that gives me 127 pictures. Also, I will divide 1,221 1/10 kilobyte by 13 to find how many kilobytes in one pic. After doing this, I find out that there are 924 7/10 kilobyte per picture. Now I multiply 924 7/10 by 127 because there are 127 pictures, and I get a final answer of 117,436 9/10 to find the number of kilobytes Adamo used at the beginning. Does your answer make sense? Use information from the problem to check your answer. Case number 5, the mystery number. Some number is multiplied by 4, and then 6 is added to the product. The result is 18. What is the number? Understand, read the problem. What are you being asked to find? What is the mystery number? What's your plan? What's your strategy to solve the problem? I will work backward to find the number. Solve it. Use your strategy to solve the problem. Start where it finished, 18. Then do the opposite of adding 6. So I subtract 6. 18 minus 6 is 12. Finally, divide the 12 by 4, the opposite of multiplying by 4. 12 divided by 4 equals 3. So the mystery number is 3. Does my answer make sense? Well, I can go back and plug it in. I start with a 3 and follow the original steps. 3 multiplied by 4 is 12. Then 6 is added. 12 plus 6 is 18. The result is 18. Check. Case number 6, ladders. You are standing on the middle rung of a ladder. If you first climb up 3 rungs, then down 5 rungs, and then up 10 rungs to get onto the top rung, how many rungs are on the ladder? Number 1, understand, read the problem. What are you being asked to find? If you first climb up 3, then down 5, and up 10 to get to the top, how many rungs are on the ladder? What's your plan? What is your strategy to solve the problem? I will climb backwards from the top. Use your problem-solving strategy to solve the problem. 10 down, 10 steps down, the opposite of going up. Now up 5, the opposite of down 5. Finally 3, the opposite of up 3. I used a number line to help me solve this problem. Here's 0. Here's where they begin, on the middle rung. Okay? First climb up 3 rungs, you're here. Then climb down 5. 1, 2, 3, 4, 5. That puts us here. Okay? And the question is, how many rungs are on the ladder? So if you count them all together, there are 17. I used a number line to recreate the ladder. I did the opposite. I worked backwards. Yes, my answer makes sense. I can follow the directions forward and backward to prove it is correct. It told me that when I went up 10, I was at the top. So that gives me the top rung of the ladder. It also tells me that I started in the middle. So if I count from the middle, 1, 2, 3, 4, 5, 6, 7, 8 rungs above the middle. So there should also be 8 rungs below the middle. Notice how this idea works perfectly with our vertical number line. The middle is 0, 8 rungs above would be the top, and 8 rungs below would be the bottom. So the question is, how many rungs on the ladder? If you count them, there are 17 rungs. That's all for now.